So yeah, welcome to the next community sync. Today is the 12th of February. So I think we first want to start by highlighting some of the key open source contributions made in the last couple of weeks. Some of these are critical bug fixes. This was in the index code path. And then we have a lot of other features that were added as well. So yeah, definitely go into the GitHub issue list and track these. But thank you very much to all the open source contributors who have spent their time and contributed back to these features. Yeah, I just want to highlight a key update in LanceGraph. So Benan and Chunshu have been driving a lot of improvements on this. And yeah, I think this ties in with a lot of the red of the other PRs that have gone in the last couple of weeks as well. So not just the core Lance repo, but also the sub-projects are also hopefully going to grow with this level of contribution. So thank you very much to all the contributors. And I think we can go into the release cycle now. And yeah, the first topic here is the release 3.0.0 for the Lance SDK.
Yeah, I think I put that. This is like, I guess the question I was asking myself. I don't know if we have a rule in the repo or not. So currently, I think we have tried 2 rounds of the major releases, and each one takes around 2 weeks because we do quite a few RCs. And so before we move to like a more semantic version release, we usually do like every release every 2 weeks. So do we want to do that like after the last release is out, or should we just start another release in parallel every 2 weeks? Well, what is our thinking on this?
I didn't even thought about doing releases in parallel. I mean, doing the releases in parallel seems like a lot more work. It probably just depends on the situation. I don't feel strongly that it has to be every 2 weeks. It is nice to like get features out regularly, but I think the ones that people are most often waiting for are usually the bug fixes, and that's I think why we make the bug fix releases more often.
Right.
Maybe so not doing parallel releases is that you might have features that might come in right after you cut, say 2.0, and then it might be if 2.0 takes a while to actually get out, then but your features are going to come in 3.0, then it might take a while before you take 3 or 4 weeks before that feature is out. But on the other hand, yeah, I guess we were thinking about doing minor releases, and maybe that mitigates that a bit. I'm not sure.
Yeah, maybe we can discuss that at the same time, which is the third point. I think we kind of discussed a bit on in chat about how can we exactly as you said release some important features and bug fixes more frequently. And one thing we kind of explored was instead of always cutting from the main branch for a minor release, we could cut a minor release from a major release branch. And I think that could work. We just need to handle the version bumps a little bit so that if the main version if we cut a minor release from a release branch, then the next main version cut, if it's not going to a major release, then it needs to skip another version. But then I was thinking, then how do we reason about, like, for example, we have, let's say 2.1 is from a release branch and 2.2 is from a main branch. How do people reason about the differences? Getting a bit confused.
I mean, from a user perspective, they don't need to care. Like 2.1 has commits X, Y, and Z, and 2.2 has X, Y, Z, A, and B.
Yeah. Also, would we like create, I'm not even sure, like when would we create this minor release branch when we haven't already bumped main with a breaking change? That makes sense?
Can you explain a bit more?
Or I guess, because you were saying there might be a situation where like, oh, like we create a 2.1 feature branch, but then we also have we're going to release 2.2 on main. You're saying, how do we reason about that? But I guess I'm saying like, well, why would we create the 2.1 release branch unless we're already like on 3.0 on main or something? I guess I'm trying to understand, like, what is the situation you're thinking of?
I see. That's actually a good point. So yeah, I think you are right. So basically, only if the next major release is the next main branch release is a major release, we could do minor releases in the release branch. I see. Yeah. That actually solves this. I see.
I think it does. Yeah, another thing I would go ahead, Tim.
I can share with you how we're doing it in Data Fusion, and it's been somewhat successful. And that is that when we cut a major release, we create a branch 49 branch dash 49, something like that, and from there all minor releases come from that branch with PRs. So you get a PR targeting that cherry picks the exact commits that you want to put into that minor release. Once they get approved, we cut release candidates from that branch, or we tag release candidates from that branch, run the release process, and then release from that branch. And then if by some reason we have something that goes into that branch that doesn't go into main, it should never happen. But if it does, because if you've been doing software long enough, stuff happens like that. Then the onus is upon whoever's approving that PR to make sure that stuff also has a parallel PR going into main. If possible. It's not always possible, right? Because sometimes, especially as main gets too far away. And then the nice thing about that is that then you can just look at those. You can look at the diff between the major release and wherever it is right now to verify that there are no API changes, no breaking pub interfaces type thing.
I see. So I guess the main difference between what we are doing today is what we create a branch every major or minor release, and the data fusion model essentially there's only a release branch for the major release, and all the minor releases also go from the release branch. I see.
Yeah. I also don't have a very strong opinion on this whole thing.
Yeah. Cool. I think what we discussed definitely works, and I guess we can hash out more details in maybe a discussion and then go from there.
Maybe Jack, you can also drop a point here to the key takeaway from all of this. Maybe as we go along, doesn't have to be right now.
Good.
Was there anything to say about the second point here, 201?
I am the release manager. I'm the release manager for the following 2 weeks, and I'm currently trying to verify this release. Now I'm studying a PR in our internal repo to test it in our integration environment. But there are some failures, and I'm currently discussing them with the LanceDB team.
Okay.
And Yeah, and hopefully, I think we can adjust them in the next 2 days and can continue or start a new RC.
Okay.
So just to summarize this point about the release candidates, like if you look at there is already a 3.0.0 beta branch, and then there's also the release candidate 2.0.1. So these are ongoing in parallel, right? Got it. Okay. Yeah. So I think we've covered all the upcoming release related topics. Can we go on to the discussions?
Sure.
I think Weston, the first one's for you. Dataset column statistics.
Yeah, I can use an update. I'm kind of in the long pull right now. Touchdown kind of has the first MVP done for writing dataset statistics. The only thing I'm sort of waffling on is like where we want to put it, but I think I'll just go with what we've got, call it experimental, and we can adjust from there. So I will clean up that PR. I don't know if anyone else wants to review it. I was just going to approve it and then go ahead and merge it since I didn't necessarily write it, but if anyone else wants to take a look, it wouldn't hurt. There's a little bit of cleanup that has to be done, so I'll get that done.
Do you have the PR number, Weston?
Not off the top of my head, but I can bring it up.
Okay. Yeah. Cool.
This is only the write path, and there's still a fair amount of work to do on the read path if we want to start utilizing these statistics in the scanner for some ways. And I think there's some questions that will have to get resolved as we start to use them. But here's the PR.
Okay. And just add it here, I guess, to the doc in case people want to take a look at it.
Yeah. So I would just say the main thing is just to consider the feature experimental for quite some time. I think we should be open to, there are changes in the manifest to make room for column statistics, and we should be open to the fact that those will probably be some breaking changes to how we do that as we go through actually utilizing these things. So I'll make sure to add that when I go and clean things up into the comments.
Cool. Looks like there are no more comments.
Yeah, I guess for the read path, so if anyone has any good ideas of like a killer use case or something that we want on the read path, let me know.
I wonder if it interacts with like the plan split stuff and Spark integration.
Yeah, I think that's probably the most immediate use case. And also, I'm working on the Trino connector these 2 days. It also plugs in pretty nicely to the Trino statistics connector.
Okay, and we could look at, I mean, plan splits right now is evaluating index searches, if I remember correctly. So those will be more accurate, but maybe the column statistics can be used when there's no index on the column that's being used in the filter.
Mm-hmm.
Yeah, I think both engines have like an independent estimate statistics interface that can be fulfilled. And I would imagine basically column stats will be fulfilling those interfaces.
Okay.
Weston, do you know your data fusion table provider? Do you push down? I can't remember if you guys do push down filtering, push down predicates, because that's, I mean, like to me, that's the first thing that jumps out is push down predicates. Because if you have statistics already, you could, you know, potentially skip, you know, entire things.
There are like 3 table providers for data fusion at this point.
Yeah.
I think they all do push down, and they all do it by utilizing secondary indexes today. So I think column statistics, I think probably what we should do is just make it simple so the users don't have to do anything. But if there is no secondary index that can be applied for a column, then we fall back to looking at the column statistics to do whatever filter, you know, simplification filtering we can there.
Yeah.
So I don't know if that's at the top of my list, but I'll document. I'll get this PR merged and I'll document what the next follow-up should be.
Yeah, those are super complicated anyways.
All right. So point number 2 is about the manifest size issue for very large tables.
Yeah, I put this up. I think we haven't really discussed this in depth. And previously, I think last year, I put a GitHub discussion about potentially manifest size when there are lots of fragments. And my personal comment was like, even for Delta, there wasn't this problem. So maybe we will just see whenever this comes up. And I think this is a time when it comes up finally that because for LanceDB, there are some internal customers that want gigantic tables, like they were coding like 1 exabyte, which I don't know if they're ever going to reach that. But if they actually reach that, this is going to be like millions of fragments, even with today the default is 1 million rows, and even if we tax that, and then assuming every row has some vector in that, which is several kilobytes, then this is still going to be several million fragments. So I think this might be the right time we start to think about if we want to do something like Iceberg to have an external manifest list, those kind of things. Just curious what people think here.
I think 2-level manifests feel to me like it's just partitioning. So like I would, maybe there's a good solution for this, but I would challenge, the question I would have for any potential solution to this would be, is this meaningfully different than breaking it into 1,000 tables? Because like we could build a composite table, and when you query it, it would query all the individual tables and then union together the results or whatever and make it feel like one table. And that would not require any changes at all to like the format or anything like that. So it's appealing in my mind. But if there's some other solution that, you know, has some potential benefits, then we'd definitely consider it.
Yeah, I have some comments for the question itself. For example, I don't think the size is the problem because Lance could have many videos and many audios. This could make this table quite large. But at the same time, it can have some only few items. So I think the problem here is if we have a table that have not much entries instead of just bytes. Yeah.
Yeah. I think this is basically if we have lots of fragments, it's not really about the size.
Yeah.
Yeah. Number of fragments, yeah.
Yeah, I mean, also, I think also worth considering, even with number of fragments, also number of files within the fragments. I'm not sure if this is like a use case we have in mind, but I think there might be machine learning use cases where we're doing a lot of add columns, and therefore we might have, tens of files per fragment or something before or after compaction. So I don't know. It might be good to like write down somewhere in a discussion like what are the use cases, or what are sort of the exact things like we want to scale on and scale on well, and then maybe figure out like what are the operations that we're worried about. Is it just like opening the table, or being able to read quickly, or figure out what it is that we need to solve?
Yeah, and I would piggyback on Sean Will and Will would say 1 exabyte is too vague. 1 exabyte of what, and what are you trying to solve? Just in the sense of like, I've seen groups chase scale factor 1000 TPCH because it's a bigger number, and therefore, let's show we can do it. But no one customer actually wants to pay for that.
Yeah. I think it would be interesting to like create a benchmark at Lance that says like, hey, let's just create like an in-memory, or maybe not in-memory, but a data set with 1 million fragments, even if those fragments are just tiny, just to see like what operations slow down and where there are bottlenecks. But yeah,
right. I think this has been coming up quite a few times from GitHub issues. That I think last time Uber did some tests that basically if you just keep appending fragments, then like for sure, because the magnifier size gradually grows, then what they see is the performance gradually becomes worse. But of course, this is they are not running compaction, which is another issue. But we should have that data at least to see where is the breaking point for users.
Yeah.
Any other points on this topic?
No other comments, and I think we can create an issue first and maybe do some math, like if we have that many fragments and how large our manifest will be.
Yeah, I can raise a new discussion.
Yep.
Thank you.
Great. Okay, so the next one is data types. We have an open issue, I believe. Oh, it's a conversation. It's a discussion.
Yeah, last time we were discussing whether or not we wanted to add string view and binary view, as well as potentially decimal 32 and decimal 64 to the logical types of Lance. Basically, I think I realized after that discussion, like the alternative we could do is just actually not introduce different encodings for these types, and actually deprecate and consolidate the existing type. So instead of having different encodings for decimals, we could just say, here's what decimals are, and you can decode them into whatever appropriate arrow type you think you want from disk, and we can have different alternative encodings, but what you decode them into memory can be independent from what the type is on disk, as long as it sort of matches that logical type. Yeah, so I put up a proposal for that, and I think that's what I lean towards moving forward with. So I wanted to highlight that here, and we can discuss that And if people have any immediate questions, happy to answer that. But we can also continue this discussion offline.
I'm definitely in the pro consolidation camp. I think I took a stab a little bit, and then I realized this was going to be a lot more work than I had time for, of taking logical type and replacing it with a trait and trying to see like what methods it should have. Thinking about this kind of consolidation. And I liked where it was going. I think there's a lot of ways that types interact. So like from input, we would always still just, like a user could still just create a table by giving us a pi-arrow table. And we would just infer a logical type based on the data type. So if they give us a string, we'll use logical type string. If they give us a large string, we'll still use logical type string. And just to further, and then I think we would also need every column to have a default arrow output type. And so like we would create a logical type of string, and then we would set on the field metadata that the preferred output is either string or large string based on what the user created. But that could always be cleaned up or changed later on without really being a schema change. That's just a DOI insert that passed of some kind.
Mm-hmm.
I think this kind of consolidation, I don't know if we're ever going to get there, but like, you know, you could conceivably get there someday. If anyone ever wanted to build a query engine that tolerated the fact that storage stores columns in many different, like you might have one batch that's encoded as string and one batch that's encoded as large string and another batch that's dictionary encoded and another batch that's FSSC encoded, just depending on the patterns in the data. And then you actually want a query engine that processes all those things. Then you need some kind of logical type system like this. So, but that's not really a compelling reason because I don't think it's a priority to build something like that anytime soon.
Yeah, but that's, to be clear, that's not a blocker for like sort of doing the consolidation of the types though, right?
No.
Yeah, and I think this is what we would do instead of implementing specific new decimal encoding types.
Just a question, maybe because of my lack of understanding for arrow. So these types in arrow, they are like actual logical types, right? Or not?
Yeah.
Arrow doesn't really have like a logical physical distinction. These are concrete types. Like string and large string are different types.
I see. I'm just thinking, if we do this consolidation, does that mean we are essentially creating another Lance type system which has logical and physical types, and we are no longer just saying that, okay, we accept whatever arrow types that are there.
There are precedents we could follow. So we could say our logical type system is substrates type system, and then our physical type system is arrows. So substrate does this type of consolidation already.
Makes sense.
The rule in substrate is that two types are different only if there are different compute semantics between the two of them, or different ranges, which, again, string versus large string technically have different ranges. The way it worked around that in substrate is they just said the range of the string type is limited to what you can create with 4 byte. Because like in arrow, when people use large string, it's not usually because they have single strings that are more than 2 gigabytes. It's because they have arrays that are larger than 2 gigabytes. And so substrate said that's fine. The string type, you could have arrays that are larger than 2 gigabytes, but you can't have any one string that's larger than 2 gigabytes. And therefore, there's no compute difference between string and large string. Every function gives you the same results, no matter which type you're using. But then it always gets, you know, these type systems, you always end up with some funny rules and like retcon, I feel, when you start to talk about int 8 versus int 16 and unsigned integer versus signed integers. Because One argument could be that you have one integer and unsigned, and all the different int widths are just different physical representations. So the logic in substrate is like, well, if you do 200 plus 200, and you're going to get a different result if you're dealing with I guess let's say 100 plus 100 if you're dealing with int 8 versus int 16. One's an error and the other is not. They have different ranges. I don't know. But stepping back, like I said in the comment, Databricks, Snowflake, DuckDB, Postgres, any database is not going to let you pick between string and large string. So I think if we pick substrate as the type system, we can do it without introducing a new type system. And we would be mirroring what other databases already do.
That sounds good to me.
The only thing is this issue or discussion doesn't mention anything about substrate. That it's the first time we brought that topic up, right, Weston?
Yeah. I'll add a comment.
Okay. Yeah, makes sense.
Okay. Yeah, feel free to comment on that discussion.
Yep, it's linked here. Right. All right, we can move on to the next discussion.
Yeah, I put this one up, although I think Nathan is not here. I think he's out of office. But just want to, because there are quite a few discussions already in this thread, trying to see what we are thinking about this topic. Because I think one thing I'd like to discuss is, do we really need to introduce another concept like snapshot? Because in my mind, the current version's API is definitely not efficient if we want to just find a specific version. But that feels like an API issue, and like we can add like a find version API, and that can do some binary search, and it can be more efficient in finding the version. I don't know, but I think well, you did a +1 on that. I don't know if you are in favor of which part of your +1. I think that's the question.
I guess my interpretation reading through it is that there weren't any real format or spec changes, that this was just a nicer API on top of the existing format. Am I wrong on that?
Oh no, yeah, you are right. There is no spec change. But even for adding a snapshot API, I kind of felt that is a bit confusing, because like, what's the difference then between a snapshot and a version?
I disagree that there's no spec changes in a way. I think it depends. So I think there's 3 discussions that are all related, but not obviously related. So this discussion, there's another discussion, which is, should we have metadata tables? And there's another discussion, which is, should we formalize the external manifest store? And if you formalize the external manifest store, that is the thing that's in charge of how you list versions. So now that's part of the spec in a way. And the API that's getting talked about here would be what that has to return, because that's the thing that's going to return your list versions. And like, if you talk about making a metadata table, well, one of the things you would obviously want to be able to do in a metadata table is like select star from versions. If you do that today, you're going to get terrible performance, which is what this whole PR is about. So we're talking about like, what is the storage format for that metadata table in a way, and that's almost going to get enforced by these external manifests. So like, these are all kind of related, and it's like, if we decide that external manifest is a formal concept and part of the spec, then suddenly this is now talking about a spec change in something that's not quite a spec.
I think maybe we could remove the external manifest store topic a little bit, because even like either way, there's only that only deals with how do we handle getting versions, getting manifests, right? And no matter what we do there, even today, the external manifest store is already a part of the stack and the commit protocol. And I don't think it really changes the like what it is trying to propose here. Or did I misunderstood?
Like if I wanted to implement a versions table, or like as a metadata table, and a user did select star on it, I think today I would go to the external manifest store, I would say list manifests, and then I would call get manifest in different times. And as long as we're okay with that being, like, I imagine that would not be very performant. They have to make, like, if there's 1,000 versions, I have to make 1,000 queries into the external manifest store or the manifest store to be able to satisfy this display versions table. And so like this whole PR is like, well, we don't have an external manifest store yet. Let's just think about our default built-in manifest store. If we wanted to make it more efficient, we could take that list call and just do that once, and that's what gets returned as the manifest table as the results of that one list call. And then if you want any details, that's almost like a manifest details table that you can't query directly or something. I don't know. I confuse myself now. But I feel like
means
they're
that
all
means
kind of
two
related.
net tables, right? Oh, sorry.
Oh no, go ahead. It's good. It's like I think the way I read this is like it's almost very specific about the way object storage catalogs work, which is take as much information as we can get from a single list call and expose that.
Right, but I think because we store the manifest creation time in the manifest, right? So technically we do not rely on the object storage, like the actual file creation time in the storage. That means let's assume there are two metadata tables. One metadata table is just the versions plus whatever we get from object storage, right? The other table is actually you load the manifest. So there's a manifest table. So there's a manifest metadata table, and there's a versions metadata table. Then the versions is, I think, literally just versions, I guess, because you only you'll be able to see the number of versions available by the listing. And you could expose additional storage metadata, but those are kind of, you do not rely on that for any purpose, ideally. And then if you want any information of the version, you still have to load the manifest, right? So I don't think there's any like real savings we could do here. We can be more intelligent in how we load, what manifest we load, depending on what use case. For example, if you do a select star from manifest, table.manifest limit 2, we can just load 2 manifests. Or if we do this time travel use case, we can do like a faster search to search for the version, and then load minimal number of manifests. But I feel that that's it. We don't need to introduce yet another snapshot concept throughout the code base. That's kind of what I felt.
Yeah, I can sort of see what you're saying. I think there's a degree to which, like, I don't know. I guess that, yeah, I'll be curious to see. Like, I guess, not sure how much we want to change the API. But I sort of see this as just changing the API part until we have a more solid idea of what we're going to do on the underlying implementation. If like the what is it? External manifest store changes things at all, or if we're sort of just keeping things as is, or if it interacts at all with the namespace API.
you want a fun idea, we could periodically materialize the versions into a Lance data set, which would be an index for querying the versions table. And then we just do like a merge on read with the new, so then you only have to read the new manifests.
Yeah, I think that I was thinking we don't have to do that. That might be too much, but we can just have an index, right, on that. And we have talked about that a few times, like having a index with the old manifests, so that you can remove that during the cleanup, but you still keep a record of what has happened in the past. I think that's in general beneficial.
I guess that's where I was thinking, like, if you wanted to let manifest stores make those kinds of optimizations on their own, you would probably need to modify the manifest store API a little bit so that it has more than just list and get, but actually has some kind of query interface.
Yeah, I think that's actually a key reason I haven't replied to that thread, because the more I think, the scope kind of expands, and I feel that maybe that's not the right way, and I was debating with myself for the past week. So maybe I should let me reply to that manifesto thread so that we can close that discussion, and then we can go back to this, I guess.
But yeah, I think Nathan's not here to defend himself. I don't necessarily know. I don't know of any compelling reason to make a spec change either, so I'm fine with what you're saying.
Right. So I guess we can follow up with Nathan when we get the chance. We have one more discussion or PR.
Yeah, this is for me, and it's my old PR in the last year. And at that time, I'm working for DuckDB, and DuckDB has a feature that the user can just select data from a dedicated version or dedicated branch. But I hit a problem that that's how can I allow a user to specify the version for a Lance. For example, Lance have an idea about branch, and Lance have an idea about version number, and Lance also have a tag. So we need to have a dedicated way to allow user to specify those reference. And our currently implementation is just to treat the reference as a number in string, I guess.
Is our current solution, if it's a number, we assume it's a version, and if it's a string, we assume it's a tag?
Yeah. I remember that there's no way for user to specify branch or tag via reference. Maybe I can prepare a dedicated proposal for this discussion.
Yeah, this is actually very in time. I think me and Dan were just having another discussion in Spark, because I think Dan, I don't know if you want to talk more, like he is trying to implement time travel.
Yeah.
To reference this.
Yeah, this came up in the discussion for Spark, because like they have the select from a table and then you like version as of, and right now like that only supports a integer version. I've seen where exactly like you said, if it's an integer, it's a version. If it doesn't parse as an integer, then it's a tag, it's a string. And then we had like some discussion that spanned off of that about like how do we support branches in this case. I think kind of in that discussion where we've all agreed from, and I don't know how this applies to DuckDB because I'm not familiar with that in depth, is that like we want to be able to support branches in all Spark SQL operations. So when we want to do like optimize or vacuum or like anything else other than just like a select statement, we can support that by like adding a branch onto the table identifier, so if you have like namespace dot table dot maybe like a B underscore branch is kind of what was thrown around. Then that adds branching like holistically into the API, where you can specify branches across every single operation that we can do in Spark SQL. Whereas if we try to integrate, specific branches into like version or tag things as part of the select statement, that solves that problem, but you have to introduce something else to do other operations. So I think there's maybe some overlap between these discussions here. I'm not sure the extent of that.
Yeah. My current idea is simple, and that I will add in 2 rules for our version. The first one is we don't allow branch and tag to have the same name. That means if we have a name called Xuanwo, and we don't allow user to use Xuanwo as a tag. So while we're trying to freeze the string, we can just decide whether it's a branch or a tag. And the second one is if user's input string is a number, then we treat it as a version number. So that also means we don't allow user to use a number as a branch or a tag. So in this way, we can just freeze our reference in a correct way, and no other overlaps.
I see. I think our proposal was a little bit different, but first of all, I think if we can agree on something in Lance core repo, then that avoids the issue about we have to come up with a solution for every engine. We should just use the same thing consistently. That's actually one problem I had with Iceberg, because Iceberg didn't define this, and well, I defined that, but then Trino decided to do a totally different thing, and then everyone decided to do things differently. So hopefully we can avoid that here. And the way I was thinking was, if it is like branch or tag related things, then we add like a ref / at the top, so that indicates some kind of reference. But yeah, we can discuss more details in this PR.
Okay, cool. I will create a proposal after the meeting, or maybe after my holiday. Okay, I think this topic is done.
I think that covers all our discussion topics. Was there any other items? All right, I think that's a wrap for today then. I guess we'll follow up with the individual PR contributors based on this discussion for folks who weren't able to make it. But other than that, yeah, thanks everyone. See you next time.